Hi everyone, thanks for checking out this video. So this is going to be another pretty quick and easy video where we're going to implement negation and subtraction. And we're going to do this in a clever way where, well, you guys will see what I mean about why it's clever, but we're going to do it in a way that only requires that we write forward passes, and then we won't need to actually write a special backward pass for either negation or subtraction. So you guys will see what I mean by that in a second. And also, just for this video, I'd like to cite Andre Karpathy's SimpleGrad, his SimpleGrad package, because this is something I learned how to do from his SimpleGrad like Python tutorial series. This is where I learned how to do this little trick with the way he implements subtraction. So I didn't invent this method myself. I'm kind of just copying Andre Karpathy's Python library here. But yeah, this is a clever way of doing it where, well, you guys will see what I mean in a second. Okay, so this is the code so far. So hopefully you guys have been following the previous lessons. So if you don't already have this code, just make sure you put all this in the beginning and then run it so we can use these functions. And then, okay, so first we're going to do negation of values. So if we have like x equals value 3, we want to be able to say like negative x, and then be able to get a value of negative 3, basically. So at the moment we can't do that. Yeah, we can't do that, but this is what we're gonna work on here. Okay, so like we've been doing, hopefully you guys are getting kind of used to this now. Yeah, like we've been doing, we're just going to import base dot minus, because we're going to be doing this thing where we override this minus operator to work on our value type. And then we're going to say function, minus parentheses with some input a, where a is a value. And then we're just going to say return a times negative 1. And then, oh yeah, then end. And yeah, so this is cool because we can actually already do this because of this. If you guys remember this promote rule we did before to make use of this like subtyping of numbers, we can actually already do this because we can do, like, if a is a value, we can already do like a multiplied by numbers. And then for negation, like negating something is just the same as multiplying it by negative 1. So we can actually already do this, and the cool thing is we don't need any backward pass, because this is, when we do the backward for this, we've turned it into a multiplication, right? We've turned this into a multiplication, and we already have the backward pass for multiplication, so we don't actually need any new backward pass for negation, because we've just turned it into a multiplication operation. And then so when we do actually do a backward pass involving a negation, it'll still do the back prop, but it'll be doing the back prop for multiplication, basically. Yeah, so now we should be able to run this code, I think, right? Yep, so now this works. Now we can say x equals value 3, negative x is a value of negative 3. Yeah, okay, and then the second clever thing is subtraction. So actually, maybe these are both going to be using the minus sign, so maybe I'll just like comment negation, and then down here subtraction. Comment this out maybe. And then, okay, we're going to say function minus, when you have an input a that's a value, and then b that's a value. So we're just going to return a plus negative b, right? So isn't this clever? This is just saying that, okay, if we have if we have if we have A minus B, that's just the same as saying A plus negative B, right? But this is clever because this way we just all we have to do for subtraction is just rewrite it in terms of addition and negation. And remember, we rewrote negation in terms of multiplication. So really, this is just rewriting subtraction in terms of addition and multiplication. Because remember, this is just saying b times -1, right? So this is just a way of writing a minus b, except it's clever because it's just using operations that we already have. We already have multiplication and addition. So when we write it like this, we won't need any new new backprop function for subtraction, because when we eventually do the backward pass for subtraction, we're just going to be turning it into addition and multiplication, and then doing the backward passes for those, basically. So, yeah, isn't that clever? Don't you guys think this is cool? I thought this was cool when I first saw it in, again, credit to Andre Karpathy for, the SimpleGrad tutorial, because when I saw it in his Python tutorial series, I was pretty impressed. I thought, this is a clever way of doing things. Because, it just makes it easier. We don't need to write a whole new backprop for subtraction. We just rewrite subtraction in terms of addition and multiplication, basically. But yeah, pretty cool. Okay, so let's just save these functions, and then we can test it out with an example. So maybe for an example, we can say like a equals value 1, b equals value 2, c equals value 3, and d equals value 4. And again, you guys can also make these like floats and stuff. The only reason I'm just making them easy numbers is just so that I can easily do the derivatives in my head and like check and make sure it's the right result. But this will work just as well if you make them like complicated decimals too. I mean, not like that, but yeah, like super complicated decimals. It'll work just as well. I'm just making them easy numbers so that I can like check the derivatives in my head to make sure it's getting it right. Okay, and then we can say like maybe y equals a times b minus c times d, and then the backward for y. Okay, let's see, print line a dot grad, so that's dy dA, which equals b, which equals 2. Again, just doing that in my head a little bit. B dot grad dy dB equals a, which equals 1. C dot grad dy dc equals negative d negative 4, and then print line d dot grad dy dd equals negative c equals negative 3, right? Okay, so let's see if this works. Okay, 2, 2, 1, 1, negative 4, negative 4, negative 3, negative 3. Okay, so that's it for this lesson. Yeah, I told you guys, pretty easy, and in my opinion, pretty clever. So credit to Andre Karpathy for teaching me how to do this kind of method. But yeah, that's it for this lesson. Again, all the code for these lessons is going to be up on my GitHub. I'll put a link in the description if you guys want to download it. And yeah, thanks for watching, and I'll see you guys next time.